Hello and welcome to Into the Terminal. We are going to be talking about local virtual machine management today, and I'm joined by my trusty co-host, Mr. Eric Hendricks.
Howdy.
So to start us off, we're going to jump into the command line and learn about command line tools for managing virtual machines. So I'm going to use the web console, and we'll talk a little bit about this later. But what I want to use in the web console is the terminal. So we'll scroll down here to the bottom entry and move to the terminal. All right, so every Red Hat Enterprise Linux machine comes with KVM, which is the kernel-based virtual machine management. And it takes care of doing all the hypervisory things on Red Hat Enterprise Linux, and it's been used by other distributions as well, but this is a great technology captained by Red Hat. To go along with this, we have a variety of tools to interact with the different virtual machines that you may be interested in running, controlling, manipulating, or managing. But to start us off, we're just going to take a look at some really basic interactions with your virtual machines. And so, for example, if you're interested to see if there are any virtual machines defined on this host, you could do a virsh list. And we can see that I have one machine running called Eric System. Yeah, that guy, he gets everywhere. And if it was not running, I could virsh start Eric System. Right, and I expect this will fail and tell me that it's already running, so that's cool. The other thing is, if you're looking at virsh list, it will only show you running virtual machines. So if you want to see everything, including those that might be there but shut down, you don't do a virsh list -all. So this machine has only one system, Eric System, that guy, and nothing else is installed or available on the machine besides this. And that's something that we're going to fix after the transition. All right, if I wanted to connect to this machine, I can use virsh console and the name of the machine that I want to connect to. So here I am connected to this machine. It's expected that this machine is offering a serial connection. So it connects to the serial terminal offered by this machine. If you don't have one configured, then it won't be able to connect to it. And if you're interested in graphical and other stuff, there's some other methods through which we would connect to that. All right, but if you're done with your console, you can control right square bracket, and that'll close the console entry for you. If you're interested in stopping your virtual machine, virsh stop and its name. I'll only try again.
You can't stop the system, Scott. You can never stop the system.
I said stop. I meant shutdown. All right, so virsh shutdown, and the name of your system, we'll go ahead and kick it off. And what that does is it sends an APCI, which is an API-based power off signal, telling the machine that you'd like it to turn off. So if you've ever went in a physical machine and you just lightly tap the power button, and it'll send that same signal and the machine will power off. However, this is Eric machine. And if we look, we can see that it's still running, despite my best efforts to shut it down.
I told you.
The system is mocking me, much like the real Eric. There is a much more severe way to shut down the system, but it would be akin to pressing and holding on to that power button, or pulling the power plug out from the machine. So this isn't a very graceful way to shut it down. Right? You would only want to use this when the system is mocking you, Eric. So virsh destroy, boom, powered off. Right? And if I do my virsh list again, it's not there, but it does show up in my virsh list -all. right? That's there and shut down. Now you'll be really, really careful with virsh destroy. You don't want to use it just because you're bored or you don't feel like waiting for it to shut down. Having the machine do an orderly shutdown keeps things like memory from getting, or I should say, queued up disk I/O from getting dumped out of memory instead of written to disk. Like there's a whole bunch of things that doing a hard power off can mess up your machine. So whenever possible, virsh shutdown. And then if something's going on where you really need it to get down now, or for whatever reason, like this one actually is not running an operating system very well. So that's why I had to do the destroy to actually get it to power off, because there's nothing there to actually receive that gentle please shut down signal. All right, Eric, anything to add to the critical path?
No, I think that's a good overview of the virsh command.
All right. Well, then stay with us as we move to our deeper dive, where we interact with our live audience and answer their questions. Also, we will be covering a little bit on using web console to interact with your virtual machine so you don't have to have the serial connections. And we're going into a lot more depth on the virsh command, including an automated installation of virtual machines, controlling networking for your virtual machines, and doing things like performance and setting performance limitations on your virtual machines. So join us after the transition. Hey there.
Well, hello. Did you know this is Into the Terminal episode 56, and we're talking about native virtual machine management today?
And if you are interested, please like, subscribe, and share with a friend.
This episode is definitely a practice of we don't change roles very well. Because before we kicked off the stream, I thought I was going to be doing the typing during Critical Path. So Scott just did it all himself. We try and shake things up, keep things interesting, but that didn't happen.
Well, but you're going to be leading us in the second part, right? Where we're going to be doing some more details on not only interacting with the virtual machines, but going into that like next level beyond basic controls on the host to more fanciness with virtual machines.
And if we have time, I even have a stretch goal of talking about really advanced things like using an image builder image with thin provisioned disks like I use in my home lab. So we'll see if we get that far.
Well, just so you know, Eric, Boss Lady and I are talking in 20 minutes, so I can't be late for that. So you might do a stretch goal on your own.
We could do an after the credit scene. That could be fun. But yeah, don't want to keep Boss Lady waiting. So with that, why don't we dive back into the terminal? What we're looking at here is the bare metal server I have here in my basement. It's called ITG1 because, you know, it sounds official and government-y. So it's the IT Guy Server 1. And something we talked about last week in terms of performance was actually TuneD profiles. So if you missed that episode, go back and give that a watch. And Scott and I were talking a little bit after the show that a lot of TuneD profiles will actually build upon one another. So when I selected throughput performance, I actually limited some of the virtual goodness that my server could be using. So what we're going to do real quick is, and if you start installing virtual machines, your console will probably pick, or your system will probably pick up on this, but there is a virtual host TuneD profile. So if you're not sure what we're referring to as far as performance, or no, I'm sorry, that was RHEL Presents this week. We talked about TuneD. So go check out that episode. We'll throw that in the show notes. But I want to go ahead and select virtual host for my performance profile. That will sort of gently tune my bare metal server here to be better equipped to run virtual machine workloads. The other thing, and we covered this on episode 30 of Into the Terminal, was the web console has an amazing has an amazing plugin for virtual machines. So you notice I've got a couple of systems here from a convert to RHEL demo that I run, and in place upgrade, and then just kind of a generic RHEL 9 system that I use to jump on and try out different RHEL 9 things. In fact, as you can see, Scott, I was all ready to do the critical path, because I even had a specifically named virtual machine just for this, and now it won't get destroyed. So, my server cries.
So one of the things I like about the web console interface is it replaces an older graphical tool that we used to ship called virt-manager. That was deprecated in RHEL 8, I believe. And so I think it's still there in RHEL 9. I've not looked, but web console allows you to connect to the graphical console of your machine. I know Eric hates servers with GUIs. I have accepted this. But if you do have a server with a GUI or a workstation with a GUI, you can connect to it, and then of course it shows you the TTYs if you're in multi-user target for systemd as well. So it's a great way to interact with your virtual machines all around, not just control them, but also like log into them and use them and make them happy.
Notice that all of my systems, you can connect to the console, but none of them have graphical interfaces.
I would expect nothing less.
That is going to be the argument that continues like all year. All right. So moving right along, there are a group of packages that we need before we can start running virtual machines on our hosts. So that would be things like the libvirt package. There's virt-install, there's qemu-kvm, and if I remember correctly, you can do a group install on virtualization, I think is what it is. I think it's virtualization to get all the necessary packages to install with your system. Now, being my virtual host here at home, I've already got all of those. So the next thing we want to talk about is how to actually install a virtual machine. And one of the tools that comes with our virtualization toolkit is virt-install. And I could type all this out, but I'd rather talk through it. So let's use the amazing copy paste function. I speak for a living, can you tell? And we'll kind of talk through this command here real quick. So the command that we're going to use is virt-install. You can use tac name to give your virtual machine a name. We'll call it into the terminal 56. Memory is how much RAM, in this case 4 gigs, 2 virtual CPUs. And we're going to create a new disk that's 40 gigs in size. Now, creating it this way, I do believe that is a thickly provisioned disk image. So that's good if you don't want to accidentally over-provision your hypervisor host. And then we gave it an OS variant, which kind of helps libvirt understand what profile to run, what fills in some of the metadata as well. So we're going to run a RHEL 9.1 system. I've got a excuse me, a RHEL 9.1 DVD on my local machine, and then this last bit here is I'm actually designating a Kickstart file that is going to use to provision my machine. And we'll throw in the show notes a list or a link to the Kickstart episode that Nate Lager and myself did on Kickstart files. So you notice that we can kick this off. Actually don't have virt-viewer installed, but that's okay. So you notice that it's going in, it's creating our boot image, and then starting to allocate the QCOW2 file, which is our virtual machine image. If you come from like say the VMware world, this would be similar to a VMDK file. There's a few others out there as well. Notice that virsh actually calls virtual machines a domain. And so you'll see in a few of the commands here in just a minute that we'll be referencing domains instead of machines or instances or something along those lines. So don't get that confused with like a URL-based domain. So what's actually happening is it's installing in the background. For the sake of time, we won't stick around and wait for that to complete, but that is running in the process. So it's currently downloading packages, it's currently setting up file systems, creating users, whatever we have defined in our Kickstart file.
Hey, Eric, could you go back to the list of VMs in Web Console and see it?
I believe so. If it's moved, yep, it has moved far enough along in the process.
And I bet we could even look at what it's doing. Oh, there you go.
There we go. There's the install screen. Which, funny enough, apparently it didn't take my Kickstart file, so.
I think your Kickstart file may just not have all the answers. So it's asking for the install language, and I think that's an install language. Maybe it's also asking for keyboard.
That might
but once
be.
yeah, and this is one of the cool things about Kickstart. If you don't answer all the questions, it will ask them, unless you're actually expecting a completely unintended install and then unattended install. Wow, that was interesting. In which case, it doesn't work out so good. But we're doing controlling VMs, not installations today. Yeah.
We actually talked about installing RHEL 9 last week, so go check out that episode. All kinds of references today. Find my terminal here.
So, Eric, one of the other things that that we didn't cover in the beginning, we were looking at our virsh list to see what's there. But some machines can carry a special tag that will automatically start them when the hypervisor boots, right?
Yes. So if we go back and look at our list of running machines versus all of our machines, we can also do, we want to look at all machines. We can actually look to see if any of these machines are set to auto start. That means when the system boots, the virtual machines will boot as part of that process as well. And you notice, for example, I don't have any machines here that are set to auto start. But what we can do is, this is going to be really, really tricky here. We can auto start ITT56. So it's marked as auto started, and then I can come back and notice that ITT56 will actually start on boot.
Yeah, so now when you boot this hypervisor, then ITT56 will also start up at boot time and be automatically running on the system. So one of the other things you alluded to earlier when we were doing the new provisioning of that system is that there's two components of your virtual machine. One is the disk image, right? And we're creating QCOW2 images, but you mentioned that like in VMware parlance, that would be a VMDK file. But there's another piece of the virtual machine definition that also goes into making a virtual machine, right?
I'm sorry, say that again.
There's another piece of the definition of a virtual machine besides its disk, right? You also have to have the description of what is included in that virtual machine.
Right, and to do that, this is why I type things in. Every one of our virtual machine domains actually creates an XML formatted configuration file, and we can actually look at that by doing a dump XML command. And because this is going to spit out a whole bunch of content, we're actually going to use the less as a part of a pipe. Let's see. So looking through here real quick, like our name right there up at the top, we can see how much memory in kilobytes. Let's see. What else do we have in here? Scroll down a bit.
We get the disk image is referenced down in there. Maybe on the next page.
Yeah, I think it might be on down a little ways. You can see what devices we have. Actually, I can type. No, I can't. It's amazing I ever get anything done. Yeah, that just scrolled me back to the top. So if we scroll on down...
Right about there.
Yeah.
Yeah, so what we're looking at here is that first disk definition. That's the backing storage that Eric provisioned for it. That's that 40 gig disk file that he made. And then you can see the next disk definition is the ISO that he attached to it. So you're given the ISO file that should be attached when this machine boots, and it will be attached, I think, every time the machine boots at this point.
Yeah, with the current configuration, yeah, it would auto attach every time on boot. Then I can just go in and do an unmount, and it won't boot on, or it won't connect on boot any longer.
If we scroll down further, we'll see things like its network device and all kinds of other virtualized devices that have been attached to the machine. You've probably seen the same information elsewhere in other virtualization tools, right? It's usually in like the system settings where you specify all these pieces, or if you want to add a new NIC card. And so we could do the same thing using the graphical interface provided by Web Console, but it's really just storing all this stuff in an XML file. So if we wanted to take this box and move it to another hypervisor, we would take the QCal2 disk image plus the XML file from this machine, and we take those two components, and that's what we would copy over to another machine, and then we use a virsh command to import the XML file into that hypervisor to use the new location of the VM. Right, but in addition to virtual machine management, it turns out that KVM also does a whole bunch of networky things.
So if we want to look at the networks that are configured on this box, and I think I just have the one. All right, there's two by default. So we can use virsh netlist. Uh-oh. Let's see.
Maybe a -- all.
That's what I'm thinking. Oh, there it is. So I think what we're seeing is because all my virtual machines are configured in such a way that they get an IP address directly from my router. So they're all, so basically what you're looking at is a flat network. A lot of times you'll have the default, which is usually set up that way, and then you'll also have a localized network that is just for the virtual machines to talk to each other. So kind of think of it as an internal communication network and an external communication network as well.
And Eric, I have the default network running on my hypervisor. So if you want, we can toggle the screens here.
Sure.
So if we do a virsh net list, the default is what you get by default. And let me make this a little bit larger. And if we do a virsh net dump XML on the default network, this is the XML file that goes into making this network and how it works. And so we see things like it will forward traffic. So my virtual machine that's attached to this network will be able to get out to the larger network outside of the hypervisor by using network address translation. Also, here's the device through which that should happen. So there's a virtual bridge device that's created on this this network, and when it's forwarding, that's the device it's using to forward to the hypervisor's attached networks. And then the default network that you get automatically also will run DNS mask, which is a DNS and DHCP server implementation. And we can see that this network or this machine is assigned 192.168.122.1, and it will serve DHCP leases to hosts connected to this network in the .2 to .254 range. So if I just start the machine up and I have it configured for DHCP, it's going to get an IP out of this 192.168.122 network. And then it will forward all that traffic out through the host's virtual bridge 0 interface out to whatever's on the other side of the hypervisor interface. So if you wanted to make changes to that, there's a virsh net edit that allows you to edit the parameters in that XML file. So you can do things like customize your DHCP release ranges and maybe the interface that it's connected to. Basically anything that's in the configuration file can be changed with this editing.
We can also gather a whole bunch of performance information from our virtual machine. For instance, if we wanted to see what the CPU was doing, we could do a virsh CPU stats and then our domain name. Of course, helps if it works. Let's see, what other systems do I have? Leap may be a better example. That's got some, I know that one's up and running.
Well, yours is running RHEL 9, which is C Group 2. And I think that's why you're getting an error here. Mine's running on RHEL 8, which is C Group version 1 by default. So here, let's toggle it one more time. You're making me get this host money today, Eric. All right.
It's payback for destroying my virtual machine.
Oh, hold on. Let me start up Eric's system. All right. So what it's telling me is like how much CPU utilization is being consumed by this Eric system across the CPUs available to my system. Why this is important is because we can actually limit what CPUs a virtual machine is able to talk to. So you can pin the virtual machine to only consume CPU time on specific CPUs instead of being able to be scheduled across your CPUs attached to the machine. Similarly, we can also do something like that for memory as well. So if we do a virsh memtune, so here it's showing me what limits have been placed on memory for the referenced virtual machine. So a hard limit is a limit that cannot be exceeded. So when we set up Eric's machine earlier, we said 4 gig. So if we told it that the hard limit should be 3 gig, then what would happen is as it tried to consume up to that 4 gig, it would hit that 3 gig limit and be stopped. What may end up then happening is swapping would occur, right? Because it's not able to actually consume any more memory. So typically you don't want to use a hard limit outside of what is already on the system. A soft limit is a limit that can be exceeded. And then a swap hard limit is if we are doing swapping, should we limit how much swap can happen? And so what it allows you to do is kind of shape the memory utilization of this virtual machine, which on my system where there's exactly one guest, we probably don't care that much about. But if you're a hypervisor where you have 10 or 20 or indeterminate number of guests because you're starting them up and starting them down all the time, you may want to make sure that guests don't stomp on other guests. Or if you're really busy one day, you don't starve out the system of resources. So you can put these limits on the individual machines to make sure that they don't overconsume on your hypervisor. All right, and then our very last thing we're going to cover before I bounce, and then Eric's going to give you the extra sauce afterwards. Eric, how do we get rid of a virtual machine?
So there was some chatter in the chat. Great job, Eric, about how you would think destroy would mean to remove when actually it doesn't. So in this case, we actually use virsh undefine, and then the name of the virtual machine. So you notice now that if we do a list dash all, oh, that's because it's running. If I do a virsh shutdown on ITT56,
You may need to destroy it because it's like stuck in that installer.
That's a good point. Destroy it. Oh, hey, what do you know? It might actually be gone now. There we go. So notice that you cannot undefine a running machine. So that was totally that was totally on purpose. But there's one other option that that you might want to keep in mind, and that's remove all storage. So all this did was undefine the virtual machine. The QCOW2 file is still there on my system. So a lot of times, if you go to remove a virtual machine, you think about removing the virtual machine and deleting the disk. So that's what we want to do with the remove all storage. So once I do that, on stop domains, helps if. Yep. See, this is why we stick to the episode guide, Scott.
We could do ITT 56.
I don't think that'll work because the domain has been undefined. So now we can do an undefined remove all storage on destroy me. It won't let you delete it because there's file locks on the QCOW2 file because it's actually actively being used. So now that the destroy me virtual machine is shut down, also destroyed, we can do an undefined, and it'll notice that it will remove the associated QCOW2 file as well.
Yeah, and I will just kind of plug a little bit of caution here. We tend to do things like attach supplemental data disks to things. If you say remove all storage, it really means remove all storage. So, it will go through that XML definition that we showed earlier and delete all of the things that were attached to the machine. So if you've attached a shared disk to the machine, or a disk that you wanted to reuse later on another replacement machine, that would cause you problems if you removed all storage from that thing that you wanted to hang on to and keep around.
Yep, very true. So that was just an incredibly brief look at virsh and virt-install. And all the, like I said, this was a very quick look at what's going on. The web console does a lot of good for about 90% of my use cases here at home. There's a few things I like to do on the command line, so it's nice to have both tools available. With that said, though, we are at time, so we're gonna let Scott bounce. Join him next week. I'll be traveling for a work conference, so Scott will be flying solo next week to talk about rescue mode. So if you do accidentally botch something during system operations, how can you go in and fix your system and get it back into a working state? So this was actually a crowd requested episode. So check out Scott next Friday at 12 Eastern to talk about rescue mode. Until then, thank you all for joining us. Stick around after the credits, so to speak, for a bit of a deeper dive. I'll show a couple of things that I do here in my home lab. But until then, make sure to like and subscribe, and we'll see you next time.
Hey, everybody.
All right, we kicked Scott out. Now it's time for some fun. I'm sure he'll watch this later, so I hope he hears that. So what I wanted to talk about very briefly was that here in my home lab on ITG1, I actually have an image builder image that I created some time ago. So something we didn't mention on the air is if you're looking for where those images are stored, they're actually in var lib virt. And so I've actually got a couple of extra directories in here, and one of them is this builders directory. This is something I created. So this is add-ons. This is extra stuff. So I actually created this builders directory, and what you see is that one, I haven't been keeping up with my image builder images here because I've got a RHEL 8.6 and a RHEL 9.0 QCOW2 file. What these are is they're about 4-ish gigs in size, and I created them using the image builder tool. So in fact, it's right here on my local machine. So I've used image builder to define basically an Ansible user, install a couple of packages that I want on all of my builds, things like tmux, vim enhanced, I think that's pretty much it. So it's a very vanilla image, but the key thing is the Ansible user in my case, because I use Ansible playbooks to further customize my systems, to run system updates, any of those kinds of things. So having that Ansible user with a sudoers entry and an SSH key is kind of the secret sauce to how I build and deploy my systems here in my home lab. So the first thing that we're going to do, and I mentioned this in the deeper dive, was that unless it's changed, by default, when you create a virtual disk, a QCOW2 file, it is, excuse me, it is thick provisioned, which means if you create a 20 gig disk, it allocates 20 gigs worth of space on your disk. So in my situation, I'm not too worried about over provisioning my hypervisor just because this server has a ton of storage. So what I like to do is I like to thin provision my QCOW2 files. So to do that, we actually have to create a QCOW2 image by hand. So if I go down into my images directory, you notice that I've got a bunch of QCOW2 files, different versions of RHEL, a couple of demos that I give on a regular basis, and the ITT56 QCOW2 file that we didn't delete during the deeper dive. So go ahead and get rid of that. In fact, let me clear my screen here. So what we're going to do is we're going to use qemu-img create-f for format, QCOW2, and then I want to put it here in the images directory, and we'll call this example.qcow2, and then you give it a size. So most of my OS disks are about 64 gigs in size. Don't ask me why. It was a round number, and I wanted to do that. So now it'll actually format a QCOW2 file, and you notice that we've got now an example QCOW2 file ready to go, and it's much smaller than some of these other disks. So we now have a thin provision disk, and then we'll want to do a virt resize. This part, let me walk through the command, and then I'll explain why this is a little tricky here. In fact, I'm not going to type all that out. So what we're going to do is notice that I mentioned that my QCOW2 file from my image builder configuration was about 4 to 5 gigs in size. So what we're going to do is we're going to grab a particular file system. We're going to grab the system disk from my RHEL 9 image builder image, which I don't think that is the right file path here. Let me double check. So what we're going to do is we're going to basically resize this this image builder image, and we're going to resize it. Oh, that's why. Okay. We're going to resize it to fit into the 64 gig virtual disk we just created. So what it's going to do is it's going to take basically a 4 gig image, and it's going to resize it into a 64 gig image. So it's going to examine it. It's going to get the file system layout, and of course there was an error. So let's see. Virt file systems. So luckily the error codes are pretty verbose. So if I do partitions, autocomplete's not working. I could have copied and pasted this, but I didn't. That should have worked. Okay. So we'll system may not boot because but hey, usually it's about SDA 3, I believe, that is the actually looks like SDA 4 on this image. So we're going to do that on builders, RHEL 9, and then we'll put it into example QCOW2. Excuse me. So notice it's regrowing the partitions. It's setting up the new partition table. So one of the fun things that I actually do with this is I pulled this out of a bash script that I have, which basically does this automatically. It's just a bash script, and then I can pass it the name of a host that I want to. So if it was going to be like ITT56 or something, I could just I could just call that bash script and give it ITT56 as a variable, and it will name my QCOW2 file. It'll set the system host name, things like that. So I mentioned the image builder image has an Ansible user configured into it. That's for this next command, because you can actually, from the host, you can actually configure settings and interact with files and place files on your virtual machine disk image. And that's what this command's going to do. So it's actually going to virt customize, and we're going to call the example.qcow2 file. We're going to give it the host name of example, and then we're going to upload off my host system sudoers file. So it's in sudoers.d for the Ansible user, and it's going to put that same file into the same place. So what this does is it basically sets up my Ansible user with the my Ansible user is basically my Ansible user is a service account that I create and use from my Ansible host to run playbooks against. So this sudoers file actually gives Ansible the administrative rights that it needs to make changes on any of my systems. So it's examining the guest. It's going to make sure that the directory exists. It sets the host name, changes the machine ID, relabels SE Linux accordingly. Okay, so that ran successfully. Now, this next command looks pretty gnarly, but we'll walk through it here piece by piece. So now, like we did in the deeper dive, we're going to do a virt-install. We're going to give the virtual machine and the actual virtual machine domain the name of example. We're going to give it 4 gigs of RAM, 2 CPUs, and then instead of creating a new disk like we did size equals 40 earlier, now instead we're going to just attach the QCOW2 file that we've been working with. Then it needs a boot ISO to do the install. This is basically just get to the installer and get it going. Actually, I don't even think I need that with importing a virtual machine. It's been a while since I've worked through my script. But we're going to import the metadata and the configuration off of the QCOW2 file. We're going to give it that OS variant of RHEL 9.0. It's going to be attached to the default network. And then some additional configuration files like auto start. So this new virtual machine will actually start on boot whenever I reboot ITG1. And of course, I don't think I need that. There we go. So that's all there is to it. So what that command did is it didn't install anything. All it did was define my virtual machine. So now you see that we've got the example is in a running state, and if we do all and then auto start, you notice that the example virtual machine is set to boot on system boot. And we can even come up here to virtual machines and notice that example is now here and running. So yeah, I did actually mess up the configuration, but that's what you get when you decide to gut your home network and start from scratch, which is what I'm doing. In fact, I'm hoping to do a blog series around. So I want to start from scratch, and how do I use all RHEL tools to basically build a home lab? So hoping to make it a blog series, maybe some live coding sessions like this. I saw Eighth Doctor in the chat. He's joined me for a couple of sessions where we've just beat our heads against the keyboard until we get something working. Looking at you, Nginx. But with that said, I know that was kind of drawn out, but it's basically five or six commands, and I can set up a virtual machine with any name, run Ansible playbooks against it, and basically come back 5 minutes later and have a fully patched, fully configured machine ready for me to install Nginx or Minecraft. Sorry, Valheim is the current rage. So 5 or 6 commands, and it's just a shell script with takes one variable. It works great. It takes 5 to 10 minutes to run, and I get everything I need, which is great when you do a lot of like live demos or you just want to spin up something, run a container image, tweak it, play with it, and then destroy it. So that's a little bit of a deeper dive. So thank you all for those of you that stuck around. I think we might try and do a little bit more content like this. Of yes, we've got a 30-minute time block where we want to talk about how to do a thing, and then maybe afterwards, occasionally have an after the credit scene where we talk about, okay, now how does this look like in the wild. So thank you all for sticking around. I'll be traveling I'll be in Dublin next week, giving a couple of presentations. So if you're in the area, give me a shout. Otherwise, Scott, you're in good hands with Scott in rescue mode next week, and look forward to seeing you guys the week after that.